Good morning, students. We already explained matter in our surroundings in previous class. Now, as a part of recapitulation, I am going to explain within few minutes what is matter. Matter is made up of particles. Of course, particles can be known as atoms. And the characteristics of particles of matter. What are the main characteristics of inside particles of matter? Inside particles of matter have space. Particles are matter are continuously moving. Particles of matter are continuously moving. Inside particles of matter attracts each other. Inside particles of matter attracts each other. These are the characteristics of matter. And matter can be available, solids, liquid and gases. And moreover, we have observed so many characteristics: force of attraction and space, kinetic energy, diffusion, density, compressibility in solids, liquid, gases, how they will differ. Now, we are going to discuss about a latent heat of fusion. What is latent heat of fusion? At constant temperature, heat is utilized to convert solid to liquid. Here, heat is utilized solid to liquid. So, this is called latent heat of fusion. Second one is vaporization. Latent heat of vaporization. At constant temperature, heat is utilized to convert the state from liquid to gases. This is called latent heat of vaporization. Latent heat of vaporization. These are the visuals. Latent heat of vaporization. Latent heat of condensation. So, at constant temperature, energy is released to convert the state from gases to liquid. So, condensation it is the process conversion of state gas to liquid. So, it is a very important definition. See the visuals. These visuals are belonging to condensation process. So, gaseous particles are converted into liquid. So, this is condensation process. Now, another one, solidification. What is the meaning of solidification? At constant temperature, energy is released to convert the state from liquid to solid. So, conversion of the state liquid to solid. See the visuals. These visuals are best examples of solidification. These visuals are best examples of solidification or freezing. So, the definition: heat energy released while changing the state liquid to solid. So, this condition can be called as solidification or freezing. And sublimation. Sublimation is the direct process. When solid is converted heat by absorbing heat at constant temperature, solid is converting gas. So, burning of camphor is the best example. So, dry ice. These are all the best examples. And see the table. Solid is converted liquid, liquid is converted gases again, solids, and next one is deposition. Deposition means it is the opposite to the sublimation. So gases are converted directly solid, not liquid. So this is called a deposition. And these are the table. Once again you can observe fusion, melting, vaporization and condensation. Introduce evaporation. What is meant by evaporation? In evaporation, these are inside particles of liquid. These are inside particles of liquid. These are surface particles. These surface particles absorbs heat energy from surroundings and they will get kinetic energy. The energy dominates force of attraction with other particles and converts liquid state to gaseous state. That means vapor state. So this is called evaporation. So evaporation is nothing but surface phenomena. Evaporation can be called as surface phenomenon. Why? Because the process only applicable for surface particles of the liquid. Next one is, whenever the surface particles absorbs heat from surroundings and the surroundings gets cooling, so that evaporation causes cooling. Evaporation, how we can define evaporation? In a liquid, the surface particles absorbs the heat and gets kinetic energy, and the force of attraction, it dominates, the kinetic energy dominates the force of attraction between other particles and gets and turns liquid to gaseous state. So this process is called evaporation. And evaporation can be known as surface phenomenon. Evaporation can be known as surface phenomenon. Next one, the surroundings, the surface particles whenever absorbs heat from surroundings, the surroundings will become cool. That's why evaporation causes cooling process. Evaporation results cooling. The process. How we have discussed about evaporation, like now I am going to introduce another topic, that is boiling. Boiling means, let us imagine these are inside liquid particles. So here what happens? Not only surface particle, here all particles inside, all particles absorbs heat energy and converts liquid state to gaseous state. And converts liquid state to gaseous states. Once again, here not only surface particles, all the particles absorbs heat energy and gets kinetic energy and convert liquid state to gaseous state. This process can be called as boiling point. Whereas evaporation, only the process applicable for surface particles. Here the boiling applicable for total all the particles. That's why boiling can be called as bulk phenomena. Bulk phenomena. So boiling can be known as bulk phenomenon. And finally, moreover, evaporation causes cooling, but boiling doesn't cause cooling. Boiling doesn't cause cooling. Now the rate of evaporation depends upon especially four factors. Once again, the rate of evaporation depends upon four factors. One is surface area, other one is temperature, and third one is wind speed, and fourth one is humidity. Generally, the rate of evaporation increases along with surface area. So that rate of evaporation is directly proportional to the surface area. And the rate of evaporation also increases along with the temperature. And the rate of evaporation also increases along with increasing wind speed. The rate of evaporation is inversely proportional to the humidity. What is humidity? Water vapor presented in the environment. Water vapor presented in the atmosphere can be known as humidity. So that rate of evaporation is inversely proportional humidity, but remaining these three factors, surface area, temperature, wind speed, the rate of evaporation is directly proportional for these factors. For this one, inversely proportional. Evaporation is directly proportional surface area. The rate of evaporation is directly proportional surface area. Better example, we are able to sip hot tea or milk faster from a saucer rather than a cup. Once again, we are able to sip hot tea or milk faster from a saucer rather than cup. Why? Because saucer provides more surface area. More surface area causes rate of evaporation, increasing rate of evaporation. This causes cooling. Once again, the saucer provides more surface area. More surface area causes more rate of evaporation, and evaporation causes cooling. And evaporation is directly proportional temperature. Evaporation increases, temperature is also increases. So in summer season the temperature is very high, so that evaporation took place at high position and the rate of evaporation increases. So that evaporation is directly proportional temperature. Whereas rainy season different. Evaporation is directly proportional wind speed, and wind speed increases, then the rate of evaporation is also increases. So from sea coastal areas, wind speed is maximum, therefore evaporation is also maximum. So evaporation is directly proportional wind speed. And evaporation is inversely proportional to the humidity. Evaporation is inversely proportional to humidity. Humidity means water vapor presented in the atmosphere. Water vapor presented in the atmosphere. So that humidity in rainy season and humidity in summer season not equal. So that evaporation changes these two seasons frequently. Conversion phase from solid to liquid, liquid to gases, in this line applying heat, giving heat should be increased. Whereas in reverse way, in reverse cycle, gases to liquid, liquid to solid, and applying pressure should be increased. And the most important, the relation between Kelvin scale and Celsius scale. Kelvin scale and Celsius scale. That is capital T minus small t equal to 273. Capital T for Kelvin scale, and T for small t for Celsius scale. And see the problem. Convert the following temperature to the Kelvin: A 25 degrees centigrade, B 373 degrees Celsius scale. One is 25 degrees Celsius and other one is 373 Celsius. We are going to convert Kelvin, and we know that the relation is capital T minus small t equal to 273. First I am doing one problem. I have taken A 25 degrees Celsius. Celsius means small t. So I have substituted in the place of small t and T equal to 298 Kelvin. And another problem, convert the following temperature into Celsius scale. So the given values are Kelvin scale. So I will do one problem. Remaining problem you can do it. The first one is 300 Kelvin. How we can solve? And we all know that the relation Kelvin and Celsius, capital T minus small t equal to 273. So 300 Kelvin means capital T is given. So in the place of capital T you can substitute 300 minus T equal to 273, and finally T equal to 27 degree Celsius. And remaining problem you can do it. Thank you.